If I pass it to something that expects the address to go back, it'll say, okay, I guess I'm supposed to pass it back address, I can do that. Makes sense? And that's important because typically in function parameters, let me just get the playground out a little bit. Typically in function parameters, we don't accept, immutable vecs because that would be kind of weird. We accept slices. Even if we know that right now we're calling with a vec, sort of generality says might as well use a slice. I'm having trouble typing play.restline.org, it doesn't seem that hard. There we go. Here's our neighborhood from the other day. Probably would be easier to start with. Oh, well. Yep, sure enough. Fun, so let's write a general version of some slice. This thing's already in the standard library, but let's write our own. We'll return a U64 because that's normally the biggest thing you would return. And we will now say, okay, so I'm going to return the sum of the elements of some slice. So what should the parameter type be for this thing, ideally? So I'm going to call it first. Before you answer that question, I'm going to make the caller, right? Yeah, right. Fun main let v equal vec colon vec. Let's say v8 equals 0 dot 10 dot collect. That look like valid Rust to you?
Mm-hmm.
Everybody good? And then of course, this is an immutable thing, and I don't really want to pass it by value so much, right? So one way to do it would be to say println bang sum of v, right? What's the problem with that plan at this point? I mean, it's not really a problem, it would work. Oh, it moves v. And I probably don't really want to have to move the thing into sum every time I call sum, right? So I'm probably going to want to pass it by address somehow, by reference somehow. So let's stick some addressy bits in front of this. And then, what would the corresponding, first of all, let's write the body of it. So it's going to take some v and, or a or something. And it'll say what? Probably the easiest way to write it is v dot iter dot sum. So this seems really silly, right? We're just going to iterate over the elements of the vector and return their sum. It's a really boring function body, right? I could write a little for loop here, right? There's nothing wrong with writing a little for loop, but man, that's pretty easy. I just want to see I just want to take all the elements and add them up, man. Now, the question is, in this context, it would probably be perfectly reasonable, right, in this particular situation, right now, in this piece of code, to write, right? Should that compile and run? How many people think this should compile and run? How many people think it should not compile and run? All right, so how many people would never raise their hand, no matter what I ask? Yeah, okay, 4 or 5. Yeah, exactly. Portrait Russells throughout the audience. Oh, it doesn't compile and run because I called the function by the wrong name. You were all wrong. Answer. Oh, okay, I didn't see it. I'm sorry. There was one person who was right in the room. They're paying attention. Good for them. Oh. Dang it. So it still doesn't compile and run. Does anybody understand this fancy compiler error message that we have here?
It's a trait thing.
You can't turn the sum of U8s into a U64.
Oh, so that might be part of the problem, right? So I probably want to be really super careful about that. We'll just do it the grossest possible way. But man, I gotta be a little careful here, right? I really gotta be a little careful, because what if I had a billion, a vector containing a billion U8s? So the obvious thing to do here that absolutely will help it compile, although it still won't compile because of reasons, would be to say, well, okay, the sum's a U8, I'll get us a U64 sum. Yay! The compiler will shut up, right? I've successfully shut up the compiler. Is this a good idea? No, because I don't want to add a bunch of U8s because I'll get a panic at runtime in debug mode, and unfortunately, because of the compiler default flags, I won't get a panic in release when I compile in release mode. All that'll happen is it'll wrap around, and I'll get a sum that's wrong. Oh wait, if you bully the compiler hard enough, you can make it produce wrong answers. What do I really want to do? Oh, so I really want to take the individual elements of the vector and do it. So how do I do that? I mean, what? Anybody? I can go back to my for loop. I don't want to go back to my for loop. I want to work in iterator world. Do we have some kind of traits that would help me with converting between different types of things? Oh, maybe a map of some kind that will actually convert the values, right? So maybe I should map a thing, right? And so I always call it E for element, which is probably wrong, but that's how, probably gross, but that's how I do it. So what should I call here? E, I could cast it, right? Is that the best way? A lot of people would say that's bad style, because in this particular case the cast works, but in general I'm kind of suspicious it won't. The thing that is actually the preferred form here would be either E.into probably, but the problem with that is the type checker is going to get lost now, because the type checker is kind of not smart enough to figure out what the into is supposed to convert it into. You could turn a U8 into a lot of things, right? So let's try U64 from E. Yeah? All right. Does that look promising? I think it's not going to compile. Why is it still not going to compile? Oh, because there's still a reference problem, because map takes this, the address of a thing. Well, let's just pattern match that address right off there. Let's see what we get now. Hey, we debugged our code. And the sum of the numbers from 1 to 10 is indeed 45. So it even produces the right answer, which is nice. And like we said, because U8s, we might want to run a better test than that. So let's do the sum of the numbers from 0 to 100. And that will give us a number bigger than 256, which is good. And what number should it give us? So somebody tell me quick, what should be the sum of the numbers from 0 to 100? Should be 50-50, I think.
Yeah. Oh wait, is it doing 0 to 99?
There we go. So what's the sum of the numbers from 0 to 99? 49 times what? 50 divided by 2. So 49 times 25, which is 1225. Is that right? Should be n minus
Times
1?
n times n minus 1 over 2.
Yeah, so it should be 1225. Is that what it printed? Nope, it printed 4950.
That's right.
Which is 0 to 99.
Oh, what did I do? Oh, 99 times 20 times, yeah, there we go. 99 times 98 over 2. I was just doing the wrong computation. 4851 is supposed to be our answer here. Yay, Gauss's sum. I got 4950.
4950 is right.
4950 is correct, because it would be 50/50 if you just take out the 100.
Yeah, I would think so. So how did I do the math wrong? Sorry, I didn't mean to stall us all here. It should be 49 times.
Oh, you did like, you did division wrong or something?
Well,
Order of operations?
49 times 48 should happen first, I think. What's 49 times 48? Dot divided by 2. Oh, now I'm getting, oh, sorry. 99 times 98. There we go. Dot divided by 2. It's 4851. I don't know. I don't know how numbers work anymore. Is it n times n plus 1 over 2?
You're 100 times 99 and that works.
Yeah, I think you're right. I think I'm just remembering Gauss's formula wrong.
Yeah,
Yeah. Okay, well, that's embarrassing. All right, everybody should know their Gauss's formula. Anyway, I think we've convinced ourselves that maybe this produces the right sum. This is the problem with testing, is you have to have good test cases. Anyway, so are we done here, really? I mean, would you ever put, yes, we're done in the sense that we have a thing that works now. Would you ever write it like this in production code? Probably not. What are the two things you'd change?
You make it more generic?
Okay, so how would I make it more generic? What would I do?
Some slice should be able to operate on vectors of any type.
Well, not any type, right? But any type that sort of, in general, any type that you can add to produce a U64 result, right? And there's sort of two ways you could do that. There's the easy way that almost nobody would ever write, and then there's, or sorry, the hard way that almost nobody would ever write, and then the easy way. Let's talk about the easy way first. So how am I going to make it operate over sort of arbitrary unsigned number types? Because I better not have it operate over signed number types, right? Because that sounds really scary. What do I do here?
Have a generic.
Oh, so I'm going to have a generic. What shall I call it? Let's call it T. And what constraints have to be on T for this to work?
They have to be summable.
Has to what?
Implement that.
Does it? I mean, it doesn't look like it here. How are we running this thing? What are we actually doing with these elements? We aren't. What are we actually summing?
You're multiplying and dividing if you're using Gaussians.
No, we're not doing the Gaussian sum. That would be the other way to write sum, by the way, which would probably be the better way, but that would only work if we knew that the things were consecutive integers. We want this to be generic over all possible vectors. But look at it, right where the cursor is. What am I doing with the element? To U64, right? So I have some pretty specific requirements on this implementation, right? The implementation has to be able to, you know, the elements have to be convertible into U64s with from. Well, or is just any type like that? Can I convert a string into U64 with from? No. What can I convert into U64 with from? Well, are there other things I might be able to? You can't do it with strings. I don't know what you can do it with, right? What specific property does T have to be able to call from U64 : from on it? The from property, right? Specifically, what I want to do is have types, and you know, this is exactly how you write this. This is part of why I wanted to go through this part of the exercise, even though it's not on the main topic for today. Is get used to this kind of thinking. U64 is is a type that you can get from a T. Yeah? Oh. By the way, all types that implement from implement into, but not the other way around. So maybe it would be more natural and better and stuff to do it the other way around so that we're more generic. T colon into U64. Maybe that would be a better way to write it. It looks a little prettier, right? And it also is more generic. What do I have to do with my program now to make that all work? I have to change my from to an into, right? Let's see if the compiler will actually, I said earlier the compiler might choke on this, and it might, I don't know. E dot into, right? Let's see if the type checker can figure this out. Cannot move out of borrowed content. Oh, why am I getting cannot move out of borrowed content? That's one we didn't expect. Where is it trying to move out of borrowed content? We could go down and look at the message, but you should be able to see it now that we know it's there.
You don't know that T is copied,
Oh, and why does T need to be copied?
because you're copying it out of your vector.
Yeah, where? Exactly where in that?
In map?
In map, in the argument to map, right? I say ampersand E. That effectively dereferences E. And then I'm going to call E dot into, right, which I'm calling by value. Into takes a value, not the address of a value. Oh, so I need a copy type. How do I get a copy type?
Derive copy?
Say something about the type implementing copy, right? I could write this. Is there a more normal way to write that? Plus copy, right? We don't need to keep renaming the thing because they give us this convenient shorthand. So I need something that can be turned into a U64 and also copied to get rid of that dumb reference, right? Cool. And now it compiles and produces the right answer. Sweet. Sweet. I'm going to call that good. Somebody mentioned earlier we could do, we could go back and do the thing that's even more general, where we say, no, it doesn't actually have to be into U64, right? We could just make it something that implements the add operation, right, with itself to produce a U64 output, right? Things that are addable into U64s are what we really want here, right? And we could do that level of generality too, but I think we were down the trait rat hole long enough. What's the other generalization that I almost certainly would do if I put this into production? Which doesn't have anything to do with the trait system, it's just a different generalization. Really easy to do. Goes back to what we were talking about literally 20 minutes ago, before we started down this road, what might I do?
This function currently takes references to vectors.
Yeah.
Argument. You want it to take slices.
Yeah, probably. Why would we want it to take a slice instead?
Because then you can use it on slices of arrays.
Yeah, then I can use it on slices of arrays, which is nice. Or slices of other things, right? I don't really care what it's a slice of. It's just a slice. And the nice thing is that vectors, if I take ampersand in front of a vector array, it'll automatically be turned into a slice for me by the deref trait. Yay! So what I want to do here is somehow fix this type. What do I want it to actually be? How do I write this? You just told me I wanted to take a slice. How do I write that down?
I don't know.
Oh, I write it like a slice, right? Let's write it like a slice, right? Yay! Oh, what did I just do? I can't
You
read
have
this.
an extra.
Sorry, my poor vision. That's terrible. My poor vision is fooling me here. I should probably make the font bigger. Like that, right? Now it takes a slice of a type. And should this still compile? I see some heads nodding yes, and those heads are correct. I will be shocked if it does not. Hey, presto. Yay! And that that version of some slice looks like something you'd see in production code. That's the kind of thing that, you know, if you dug into somebody's well-designed, well-written crate, you know, that's almost certainly about what people would write. Like I said, they might write the fancy thing with add, but yeah. Because that's sort of free generality, right? It isn't like we had to do much, right, to make it take a slice of things that are convertible into U64s. It isn't like we had to work hard or think deeply, right? And sort of by getting that level of free generality, well, maybe somebody will use that someday. I'm in general, sorry, that's a terrible way of saying it. I am normally a big opponent of prematurely generalizing your code. You should normally write the most specific thing that will work and generalize later when you need it. But this is a good example where really the community standards and the community idioms say, no, you're supposed to generalize here. Because otherwise, you know, because why not? And because now your code gets actually harder to read because we're trying to figure out why didn't they generalize it? Make sense? Yeah, just a sec, yeah.
Can you, is there a reason why you would ever do it with a vector address rather than a slice? It seems to me like they're functional.
Maybe there are operations on vector slices, vectors that are by reference that aren't provided for general slices, right? For immutable vectors, I feel like there are, but I can't name them off the top of my head. Let's go look in standard vec. It's a great question. Let's look in standard vec and see if there's something that I can't support now in the body of some because of that. See if we can find any functions that take their vector, any methods that take their vector by immutable reference that are special to vectors. Blah, 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 blah. That one's just, those are creation functions, they're boring. We're looking for ampersand self, not ampersand mute self, but just ampersand